All right, so a pleasant good evening to everyone. Welcome back to another week. Our final class of week number 3. We are going to be heading into our fundamental night. Can somebody confirm that tonight is fundamentals night? I believe last class we had looked at measurement. So is tonight the fundamental night? Can somebody confirm?
Yes,
sir.
Okay, tonight is fundamentals night, all right? So we're going to be diving into that. I'm very happy to see you all. I'm happy to see that everyone is here in attendance, 44 persons. So that's good. So let's get into the meat of the matter and let's get something tied up under our belts, okay? And let's end this week in the best way possible, all right? The recordings for this week class will be posted on Sunday. So in the event that there's someone here that did not get a chance to join the class on Monday, then you'll be able to access that recording sometime on Sunday between the hours of 12 p.m. in the afternoon through to 5 p.m. You'll be able to access both recordings this Monday and tonight's class, okay? So fret not thyself. You should be okay once you are subscribed to the channel, all right? All right, so let's get right into it then. Tonight, we're going to be going back to let's pull up our whiteboard here. Okay, and I believe that on our whiteboard, I'm so sorry, this was a lesson I was doing last night, so that's not my class. All right, so in our last class, we would have completed the topic of approximate a number to a given number of decimal places. We would have learned how to approximate a number to the nearest whole, and we would have also learned how to approximate a number to a given number of significant figures, all right? I'm going to skip past the whole concept of standard form. It's more physics related than it is math. It's not a major topic, but in the event that it does pop up, I will show you it's not a complicated concept, but I don't want to take my class time going through it because it's not a major topic on the syllabus. So I want to get into more important details about what we're doing tonight, okay? So tonight, ladies and gentlemen, we will be doing operations with fractions. That's going to be our topic for tonight. Operations with fractions. I think I really need to title these whiteboards now because they're all over the place. All right, so as you can see here, for those who are joining the class for the first time, I think I have one newcomer. Somebody messaged me this evening saying that you're new. You want to introduce yourself, or you rather stay quiet? I sent the person the link this evening. You want to introduce yourself, or you're okay? Assuming that the person is quiet, so they probably do not want to really make themselves known. That is fine. Anyways, welcome, and I hope that you enjoy the class. All right. That is if the person is here, anyways. And just give me a second here. All right. Nope, that's not it. But I'm guessing that this must be it then. $2025 must be this. So either ways. All right. So, ladies and gentlemen, let us do a quick little recap before we get into what we need to get into tonight. All right, good. So let's scroll down here. So in our last class, we would have been looking at the following. All right, as you can see here on screen, as we're zooming up, we looked at approximation, the definition of approximation. We looked at the rules for approximation. We did a couple of examples of nearest whole. We also did a couple of examples for significant figures, we looked at whether 0 has a value or doesn't have a value, so we can estimate if the number is significant. We also did a bunch of examples as well, and then it brought us to this point right here, all right? So I'm going to put 3 questions on the screen just to quickly reiterate what we had done the last class. All right, so here we go. So we are going to be asked to approximate, give me a second here. We're going to be asked to approximate approximate 0.004765. And let's say that we wanted to approximate this number to the following. 1. We want to approximate it to 3 significant figures. We want to also approximate this number to, say, 3 significant figures. Like, let's do 2 significant figures. I'm sorry. Yes, go ahead.
Some persons got kicked off because they had light
Okay, all right.
problem. They're asking to be let.
Okay. Okay, gotcha. I'll let them back in. All right, so we are asked to approximate the number 0.047615, and we want to approximate this number to 2 significant figures. We want to approximate it also to 3 decimal places. All right. All right. So in the event that we get a question like this, right, they may or may not use the word approximate. They may use round off, or they may say write your answer correct too, and they'll give you the following. Now, based on the rules that we had discussed last class, we said that if we have a number that requires rounding off, when it comes to significant figures, we have to pay attention to the zeros.
Excuse me, sir.
Yes, go ahead.
Somebody in the group has got kicked out and they are typing that they want to rejoin in the Zoom class.
Yeah, but they're not in the waiting room. As you can see on the screen, nobody's in the waiting room. So I'm not sure what's going on that end, because nobody is in the waiting room. All right, here we go. So when it comes to significant figures, bear in mind that zeros have no value, especially if they appear before a number that's greater than 0, right? So in this case, my second significant figure would be right at the 7, because these zeros have no value. All right. So then, according to the rule, we are going to check the number that comes after that line. And if this number is greater than or equal to 5, we would increase 47 by 1. So our answer for this would have been 0.0048. All right. So now we can see that there's only 2 significant digits there. All right. And for 3 decimal places, we don't consider the zeros. For decimal places, the zeros aren't paying attention. 0 still holds a place. So regardless of whether or not, regardless of the 0 being significant or not, when it comes to decimal places, we have to take in account the zeros as well. All right. So in this case, now we want to round this out to 3 decimal places. Then what we're going to be looking at then is, give me a second. Okay. Give me a second here. All right, we're back up. All right, so when it comes to decimal places, we don't mind. We have to just pretty much look at the decimal places. The zeros doesn't play a role. So in this case, then my first decimal place would be this 0. Second decimal place would be this 0 here. And then my third decimal place would be the 4. So I would draw my line here. For some reason, guys, I don't know what's going on with my pen tonight or the screen. Give me a sec. Hold on, guys. I'm so sorry. Give me a second. Let me just try to see if I can. The device is just overheating crazily. All right. Do apologize for the glitch, guys, but it's technology, so it does give its own problems. I'm gonna try to do my very best to try to get it working. So hopefully it doesn't go out again. All right, so hopefully it doesn't go out again. So now the 0 would be the first decimal place. The second 0 here would be I don't know what's wrong, guys. I don't know what is wrong. I don't know what is wrong.
Sir, your screen went out.
All right, guys. Are you seeing the screen now?
Yes, sir.
All right, let me see if it's working now. I was trying to restart the device, but I don't know. Let's see. I really don't know why this is happening tonight, because everything is good with my pen. Everything is good. Okay, so I think I'm good now. Hopefully it doesn't make a mess again. All right, here we go. All right, guys. So hopefully you're still with me. So the first 0 would be the first decimal place. The second 0 would be the second decimal place. And then the 4 would be the third decimal place. And as we're looking for is 3 decimal places here. So we draw the line here and we check the number that comes after. That number is 7, so it is greater than 5. So therefore then, we would increase the 4 by 5. So our final answer then would have been 0.005. Okay? All right. So do apologize for the technical difficulty, but it's technology, so we have to do our very best and see what we can do. All right. But like I said, guys, if you guys would love to get a thorough review on this, you can always visit the recording that is posted on my YouTube channel. Okay, but let's get into what we really want to get into tonight, which is going to be operations with fractions. So let's get into that then. All right, operations with fractions. Let's grab our notepad here, pull it up. So tonight's topic is going to be operations with fractions. All right, so I hope everybody's ready. We have an hour to try to get some stuff done here. Operations with fractions. All right, so usually whenever I'm teaching this topic, over the years, I would just fill up my students with a bunch of notes. All right. And what I've found based on the statistical proof and evidence and, just how they behave after you teach them the whole entire topic is that I find a lot of the students don't really love to read, or even if they don't love to read, they don't like to read over notes. So what I do is that I've changed the way how I go about teaching the topic. I rather just give you the information that you need to know. And so, go ahead. All right, so for operations with fractions, then there are a couple of things that you guys are going to need to know in regards to learning how to work fraction questions effectively. All right, so we're going to kickstart with a very basic definition of fractions. We're going to say that a fraction is a quantity. Oops, sorry. Here we go. All right, so here we go, guys. A fraction is a quantity that is less than a whole. A fraction is a quantity that is less than a whole. And when we say a whole, we are referring to the number 1. All right. A fraction is a quantity that is less than a whole. So pretty much we are going to be dealing with numbers that are going to be between 0 and we're going to be dealing with numbers that are between 0 to 1. All right, so we're gonna be dealing with in numbers like a half, a quarter, 2/3, 3/5, negative half, negative a quarter, negative 2/3, negative 3/5. So we're gonna be working with numbers in between this range here, 0 and 1, and 0 and -1, and 0 to -1. 0 to -1. Here's my minus. Okay, 0 to -1. All right, that's what we're going to be working with in this range. All right. Now, next thing is that we need to understand how a fraction is expressed. A fraction is expressed in the form and we write it like this. small n divided by small d. All right, so a fraction is expressed in the form n over d. I'm going to assume that everyone in here knows that n stands for the numerator. So n implies n equals the numerator, and d, let's write small d, guys. D equals the denominator, right? Denominator. All right, so this is just kind of like some refresher for most of us. For most of us, I doubt that there's anybody in here that is not familiar with what I'm talking about already. So it's just a couple of reminders before we get into the meat of the matter. All right, so a fraction is expressed in the form n over d. N is the numerator, d is the denominator. All right, moving right along now, we're going to be looking at the types of fractions. So all of what I'm giving you here on screen is just the most important information that you need. All right, there's a lot more to fractions, and understanding the intuitiveness behind fractions, but we're not going to do that because we're mostly interested in the calculation as opposed to everything else that matters. All right, because a lot of this stuff we should have learned it from like grade 2, grade 3, grade 4, but we just want to know the most important thing as it relates to CXC. All right, so types of fractions. There are two types. All right, some teachers will tell you that there's 3, but there's actually 2. All right, so the first type of fraction is what we call a proper fraction. A proper fraction. And the second type is going to be called a improper fraction. All right, improper fraction. All right, and so there is also an extension to this, right? Some still improper fraction. I'm going to put like a little forward slash here. So improper fraction is also called mixed fraction as well. Mixed fraction is just that the improper fraction can be expressed as a mixed, all right, but it's not separate. Okay, well, at least I don't think it's separate. All right, some textbooks may tell you that there's 3 types of fraction: proper, improper, and mixed. But when you think about it, improper can be expressed as a mix. We're gonna look at that shortly. Okay, so proper fraction, and we have improper fraction as well. All right, so information now as it relates to proper fraction. What about it? So a proper fraction, and I'm going to write it on screen here, see if you can read this information for me. N, and watch this now, is, okay, oops, okay, N, D. Can anybody read that? Proper fraction means that N is less than D. I should use the other symbol, my bad. Okay, that's it. All right. So with a proper fraction, we're looking at where the numerator is actually a lesser value than the denominator. All right. I don't know if you guys want to write that in words in your notes, or if this N less than D symbol is suffice, right? So proper fraction, N less than D. All right. So if I want to write it in words, I'm going to write it for you. Numerator is less than denominator. And denominator. Okay. All right, let's look at some examples of proper fraction. We're going to have something like 2 over 3. That's a proper fraction. All right, and then we're going to have, we'll put a comma here. Let's put another one here. We have 3 over 4. 3 over 4, that's also a proper fraction as well. The comma again. Let's look at another example. We can look at 4 over 5. 4 over 5. And then we can put maybe 2 more examples. We can put like say 5 over 8. 5 over 8. Okay. And then we also have 5 examples, right? 2 over 3, 3 over 4, 4 over 5, 5 over 8. I'm gonna put 6 over 11. Okay, 6 over 11. So 6 over 11. All right. And then we're going to put some and so on and so on. It continues. Yeah. So you can make these up all day. So if you look at these examples, you realize that the number at the top, the 2, the 3, the 4, the 5, and the 6, they're all less than the actual number at the bottom, 3, 4, 5, 8, and 11. All right. Good. So that's our proper fraction. So by logical reasoning, then we can actually just come up with a definition for an improper fraction. So an improper fraction is one where the n is in fact greater than the d. Okay, so it's greater than the d. All right, and then I can write it in words for you. Numerator is greater than the denominator. All right, lovely. All right, so once we've been through that, then let's look at some examples. We can actually just flip these around, all right? Instead of just changing up everything, we can just flip it around. So we can just say, instead of saying 2 over 3, we just say 3 over 2, all right? That's an improper fraction, okay? And then we're going to put a couple more examples as well. We can just flip that one around and say 4 over 3, right? Don't want to change the examples. So that's going to be 4 over 3. Put a comma here. Let's do 5 over 4. 5 over 4. All right, and then we're going to put 2 more examples. That's 8 over 5. And they continue like that, okay? As long as the number at the top is larger than the number at the bottom. Okay, and then we're going to have 11 over 6, okay? 11 over 6. All right, so and then we're going to have and so on, and it continues like that, okay? And that's a improper fraction, right? And then now we know that a mixed number or a mixed fraction is a combination of a whole number and a proper fraction. All right, so a mixed fraction is a combination of a whole number and a proper fraction. So what we're looking at is stuff like, say, 1 and 1 over 2. All right, that is not, let me just put a space between this here. Okay, let me put a space so you don't think it's 11 over 2. So that's 1 and 1 over 2. All right, there's a space between there. So please, guys, remember, it's not 11 over 2, it's 1 and 1 over 2. I'm using the keypad, so it's not going to give me what you want. I'm going to write it in hand shortly. So 1 and 1 over 2, and we can do something like 2 and space, and then we're going to have 2 and 2/3, 2/3. So that's 2 and 2/3, and then a comma. Let's put one more example: 3 and 3/4. So 3 space and 3/4, and we can put and so on. Continues like that, okay? All right, good. So we've gone through the preliminary details of this. Let me see the chat. How is the chat looking? Everybody understands? How is it looking? Everybody up to speed? Everybody understands what we're discussing so far?
Yes, sir.
Awesome sauce. Yeah, man. We just want to say everybody understands all that information that is being laid out. Everybody's clear? I'm seeing the thumbs up going up. There's 44 of us in here, so I need to see more.
Please come back to the whiteboard.
Yeah, man, I'm going to the screen. I'm just wanting to see the chat to make sure everybody is good. That's how they communicate with me. All right. I'm not seeing any thumbs down. That means everybody should be okay. Or everybody is okay. All right. We didn't see 44 thumbs up, but that's fine. All right. Try to use the chat, guys. That's your way of communicating with me, not everybody, okay? Or you can use the chat to text. All right, good. Lovely. All right, so you said you wanted to see. All right, so we're going to save that right here. All right, going to move this information here. Oops. All right. All right. Good. So Those are the preliminary information or the prerequisite information that we need to get into what we need to get into. All right. So we learned the three types of fractions. Well, two types along with the extension, mixed fraction. So now our next objective then is to look at the most important part, which is the conversion. Okay. So conversion. All right. And there's two conversions that we are going to need to do whenever we are doing fractions. And the first type of conversion is going to be the mixed fraction being converted to, pardon me, mixed fraction that we're going to need to convert to an improper. This is most likely the first thing that you're going to do when you're solving a problem. So mixed fraction converted to improper. All right. So how do we do this then? How do we convert a mixed fraction to an improper? The best thing to do here is to get into an example. Nothing better than an example, guys. Nothing better than that. All right, so let's see here. Go ahead, question.
Could I, I'm not seeing the last part of the examples that you were showing just now, where you have the mixed fraction combination of a whole number.
Hold on, give me a sec.
Thank you.
You mind taking a picture? Because once I close the notepad, then it disappears. You got it?
Wait. Okay, thank you.
Okay. All right. So mixed fraction to an improper. All right. So let's look at some examples then. All right. So let's say we end up with a fraction such as 2 and 3/4. And for whatever reason, the conversion is required, right? So here's how we do it, ladies and gentlemen. We're going to take this number at the bottom and we're going to multiply it by the number at the side. All right. So we're going to take this number. So we're going to take the number, we're going to take the denominator, right? We're going to multiply it by the number at the side here. And then we're going to add the number at the top to it and then put it back over 4. All right. So the process is going to be like this. 4 multiplied by 2. And then we're going to add 3 to the result and then put back everything over 4. All right. You don't need to write it out like this, ladies and gentlemen. You just need to do it mentally. I'm only because I'm teaching, I'm just writing out what I'm thinking. All right. So I'm taking the number at the bottom, which is the 4, and I'm multiplying it by the whole number, which is 2. When I get that result, I'm going to add the top number to that result, and then I'm going to put my entire result back over 4. So in terms of writing it out, that's what it would look like. 4 times 2 plus 3 all over 4. This would then work out to nicely be 11/4. All right. And again, this is not necessary. You do not need to do that. Okay. Because you're not going to have enough space in the question to do all of that writing. We the markers don't need to see that. You just need to do it in your mind. Okay. All right. So let's look at this then. Let's look at example number 2. Okay. Number 2. All right. So we're going to go ahead then and look at, say, let's look at example number 2. Let's say we have 3 and 2/3. 3 and 2/3. All right. So what we're going to do then, guys, is that we're going to take the number at the bottom, which is the 3, and we're going to multiply it by this 3 right here. And then now when we get that result, we're going to add 2 to the result, and then we're going to get an answer of 11/3. All right, because 3 times 3 is 9. 9 plus 2 is 11, and that's 11/3. All right, and then just do one more example now to just really tighten it up to make sure that everybody is good. Okay, we're gonna therefore then go ahead and do another one. Let's do something like 4 and okay, I don't know what kind of 4 is that. So we're gonna have a number like 4. Give me a second. All right, so we're gonna have a number like say 4. Oh, sorry, my pen is off. It's not ready. We have a number like 4 and 4 and 3/8. So 4 and 3/8. Give me a sec. I think my pen battery is dying. Hold on. Let me just use my fingers. Okay, so 4 and 3/8. So forgive me, guys, if the numbers are not writing as clearly as before. I'm using my fingers to write now. So 4 and 3/8, that's going to be equal to. We're going to use the 8 to multiply the 4 right here. So that's 8 4s is 32. And we're going to add the 3 to 32. We're going to get 35. And that's going to be all over 8. All right? And that is how you convert a mixed fraction to an improper fraction. Okay? So I'm going to pull up a little notepad here just to specify why do we convert a mixed fraction to improper. Well, most of the time when this is required is when we are beginning to solve, to evaluate. I don't want to use solve, evaluate the problem. So usually you're going to do conversions of mixed to improper at the very beginning of the question. It's when we are beginning to evaluate the problem. All right. A fraction problem is easier evaluated when it's in mixed fraction form as opposed to being, is it improper form than when it is in mixed fraction form. Right? So I just needed to jot this little note right here for you. So you remember why we are doing it right here. Okay, we're going to drop it right here. So that usually happens when we are beginning to evaluate the problem. Okay. All right. So obviously we are going to give you just a few to try to make certain that you guys are on the right path. Okay. So go ahead for me and just do quickly these two. Okay. I'm just going to give you like a minute to run through these two questions here. All right, so please convert the following mixed fractions to improper. 5 and 3/7. That's 1. And then let's give it 3. We're gonna have 4 and 5/9. And then we're gonna have something like 3 and 6/11. All right, just making it a little bit more complicated as best as I possibly can. Okay, it's not going to really get this hard, but okay, so I'm giving you a minute, guys. Quickly, 1 minute in order to go ahead and get this done. So 1 minute. Your time starts when the timer begins. Okay, 1 minute to go ahead and convert. Thirty seconds to go. All right, your time is up. So that means you should have gotten. Okay. All right, so that means you would have gotten, say here, 7 times 5 is 35. 35 plus 3 is equal to 38/7. If you got that, thumbs up to you. Good job. And for the next one, then you would have had 9 times 4 is 36. 36 plus 5, that's going to be equal to 41 over 9. And then your final one over here, let me just grab some extra space here. Would have obviously been, let's get some space over here. This is going to be 11 times 3 is 33. 33 plus 6 is going to be 39 over 11. All right, so thumbs up to you if you got those correct. Awesome sauce. Okay, good job. All right, good job. Good job. All right, I've seen some answer coming in the chat as well, so that's good. That's really good. All right, so that's how you convert from a mixed to an improper. In a moment, we're going to need that skill set to do what we need to do tonight, okay? Now we're going to be doing the opposite now, right? If we can or we are allowed to convert from a mixed to an improper, then naturally then we are going to be able to convert from an improper back to a mix. And so why do we need to do this? I'm going to let you know that in a second. Why do we need to convert from an improper back to a mix? So just give me a few minutes. Let me just grab my screen. As usual, technology is just doing its own thing. So let me just try my very best to try to get it up and running for you here. All right, here we go. All right, so now our next version is going to be improper. Oops, pardon me. It's a little bit too small. All right, so now we're going to be looking at the improper conversion back to a mix. All right, and so pulling up a little notepad here to tell us why we have to do this. All right, so in terms of why do we have to do this conversion from improper to mix, this is required in order to express.
Not see your screen, sir.
You're not seeing my screen? Thank you very much for telling me.
Screen's gone.
All right. Give me a second, guys. I'm going to share it in a sec. Hold on. All right. In a couple seconds, you should see it now. All right. You guys should be seeing it now. Let me know if you jump off again here. In order to express, this is required.
Someone
in
was
order to express.
someone was kicked off and want to get back in. Someone was kicked off and want to get
There's
back.
nobody in the waiting room. Yeah, but I'm saying nobody's in the waiting room. I'm looking at it.
They
There's nobody
texted
in the
in the
waiting
group.
room.
They just texted in the group.
They're not. Yeah, but they're not in the waiting room. That's what I'm saying. There's no one here for me to let in. All right. So back to this here. Why do we need to convert from an improper to a mix? This is required in order to express our answer in its lowest form. So this is required in order to express our answer in its lowest form. So once the question says express your answer in the lowest form, it more than likely means that if you end up with an improper fraction at the end, then it means that you need to convert that improper fraction back to a mix. So here we go. So let's say we end up with something like 11/6 as our final answer, and we therefore need to convert this 11/6 back to a mixed fraction. So therefore, your task now is to figure out how many times can 6 go into 11. So 6 can go into 11 one time. If you add another 6, you're going to pass 11, you're going to go to 12. So we can't add another 6, it's going to be one time. It's going to leave a remainder of 5, and we're going to put that back over 6, all right? So it's going to be how many times the denominator goes into the numerator. We write that result, and whatever the remainder is, we put that remainder back over the denominator, right? Now, another example would have been, say, we end up with, say, 13/4. Now, our task is to find out how many groups of 4 can we extrapolate from 13. And so 4 plus 4 is 8, plus 4 is 12. We're very close to 13, so that sounds like about 3 times. Because we're at 12, we need one more to make 13, and we're going to put that back over 4. So that's 3¼ okay? And then we are going to look at another example where we end up with something like 17/3. All right, so how many groups of 3 can we get from 17? Your timetable is going to play an important role here. So 3 plus 3 is 6, 6 plus 3 is 9, 9 plus 3 is 12, 12 plus 3 is 15. That sounds like about 5 times. Now, since 5 3s is 15, we're going to need 2 more to make 17, and that's going to be placed over 3. All right, and that is how you therefore then convert a improper fraction back to a mix. All right, so just to ensure that you guys understand, I'm going to obviously give you just 3 of them to convert real quickly. I'm just going to give you a quick little minute to run through that. So please convert the following fractions, improper fractions to mix. You're just going to get a minute to do so. Okay, go ahead and do this one. 15/7. Then we're gonna have 19/4. Then we're gonna have 6/5. So go ahead and convert the following fractions back to a mix. All right, I'm going to give you a minute. Here we go. All right, so your time is up. You should have gotten, for this answer, you should have gotten 2 and 1/7. 4, you should have gotten here 4 and 4, 4, 16, 19/4, 12, 16, 20. 4 and 3/4. And then you should have, let me just say this on a 9. This is 4, 4 and 3/4. And then you would have gotten for this one 1 and 1/5. If you got all three right, just give yourself a hand or a thumbs up. It looks very basic, but remember that there are persons here who genuinely never know how to do this. So if you're doing it right, thumbs up to you. Good job. All right, awesome. All right, lovely. So now we have the tools that we need to execute what we need to execute. Good job, Mr. Finn. All right, basic math so far, nothing too saucy. Now we're going to get into the meat of the matter because we needed the tools. We needed the tools to get into what we are doing here. Okay, so now we're going to be heading into what is known as addition and subtraction of fractions. All right, so that's essentially what we want to do, adding and subtracting fractions. All right, here we go. All right, so our topic is going to be addition and subtraction. Oops, I don't know what kind of sub is that. So addition and subtraction of fractions. All right, so again, I'm going to pull up a little notepad so our information can be a little bit more legible. All right, so in terms of the rules for adding, let's just put that out there from now that the rules for, pardon me, I don't know what that is. So the rules for adding and subtracting fractions are exactly the same. All right, so we don't have a different rule for each. Same rules that applies for addition is the same rules that apply for subtraction. All right, so let's put that out there as well. Let's go back into the tab. Let's go back into the notepad here. Give me a sec. All right, good. Full stop. Okay, so here are some rules, guys. Step one, steps. Okay, steps. I'm gonna list them. So steps. First step is to find the LCM. All right, for those who don't know what that means, it means the lowest common multiple. All right, in a second I'll show you how to find it. Lowest common multiple. All right, now the second thing is that we're going to do is we are going to divide the LCM. We're going to divide the LCM by each denominator and multiply the result by the numerator. By the numerator, right? Last step is to add or subtract respectively. So add or subtract, add and / or subtract respectively, right? Subtract respectively. And why do I have that and or in the middle? Because sometimes you get a question where you're adding and subtracting at the same time. And sometimes you have to add or you may have to just subtract. So that's why we have that add and or subtract respectively. All right, so these are the three steps that you need to follow. Let's just move this information to the side here so you can realize that those rules are going to be applied, okay? Let's just move it right here. Okay, perfect. All right, in the event that you need those information, there. All right, so let's get into some examples of applying these 3 steps here. Okay, so let's say that you are asked to calculate or evaluate. This is the word that we use when it comes to fraction. Evaluate. That's the word that we use. Evaluate. Let's start off with the basics. We're not going to rush the class because rushing the class makes no sense. I may have to teach over if I do that. So evaluate 1/2 plus 2/5. All right. So step 1, ladies and gentlemen, is to find the LCM. And so to find the LCM is where we simply draw a line at the bottom here. And then we're going to multiply the 2 numbers that is right here. We're going to multiply this number with that number here. Okay. All right, so we're going to multiply the 2 and the 5. Okay. So therefore, 2 times 5 is going to give us 10. We're going to place the LCM at the bottom of the line. So we find the LCM by multiplying the 2 numbers at the bottom. All right. So that is going to be step 1. That's how we find the LCM. Multiply the 2 numbers at the bottom. Step 2. Each of those denominators will be divided into the denominator. So 2 will go into 10 5 times. We're going to put that 5 at the top right here. And then 5 into 10 goes 2 times. We're going to put that 2 right at the top here. Okay. So 2 into 10 5 times. Put that 5 at the top. 5 into 10 goes 2 times. Put that 2 at the top. Okay. Then we're going to proceed now to say 1 times 5 is 5. And 2 times 2 is 4. So we end up with a really nice simplified answer of 9/10. All right, so our answer there is 9/10. There's no need to do any form of conversion because 9/10 is a proper fraction, and a proper fraction is already written in its lowest form. Okay, so that is going to be 9/10. Lovely. Next, number 2. So that's number 1, number 2. I'm going to check the chat in a second to see if everybody is on schedule. All right, I'm going to check it in a second. All right, in fact, you can go ahead. Hold on. Let me see here, guys. Give me a sec. All right, so you guys can go ahead and give me the thumbs up. Let me see if you guys are good to go. Everybody's good thus far? Not seeing any thumbs up. Everybody's okay? I'm seeing thumbs up from Tishana, Mikoya. All right, I'm guessing that the reactions is somewhere. I'm not seeing it, but all right. I guess everybody's okay. All right, so moving on next then. We have 3/4 minus 1/5. We're going to find the LCM. I see you, Simone, and I see you, Latisha. Good, thumbs up. Thank you very much. I see them. I'm seeing them, guys. Once you make a reaction, I'm going to see it. All right, good. So we're going to draw a line here. And then we're going to find the LCM. Remember that the LCM is obtained by multiplying the 2 bottom numbers here. 4 times 5 is going to give us 20. All right. Now, from we have that, 4 into 20 goes 5 times. Put that at the top here. And 5 into 20 goes 4 times. Going to put that at the top there. All right. So 3 times 5 is going to give us 15. And 4 times 1 is going to give us 4. So that works out to be 11/20. Okay. 3 times 5 is 15. 1 times 4 is 4. So that's 15 minus 4 is 11/20. All right. And 11/20 is a proper fraction. So therefore, we have arrived at our final answer. Okay. We have arrived at our final answer. Right. Lovely. Right. Want to see some thumbs up, guys. Everybody's up to speed. Remember now, one time we are teach this enough.
Sir, go into over again one time.
Which
please.
part? The second question.
All of it.
The second question.
Yes, sir.
Step 1, multiply the 4 times the 5 to get the number at the bottom, which is 20. Then you divide the 4 into the 20 and write the answer right at the 3 here. Okay, so this 4 goes into this 20 5 times. Put the result you get at the top. Then you put this 5 into this 20, and then you get 4. You put the number 4 at the top. 3 times 5 is 15, and 1 times 4 is 4. 15 minus 4 is going to give you 11, and you put that back over 20. All right, clear?
Yes,
Clear,
sir.
clear? Okay. Nisha, is it clear?
Yes, sir.
All right, wonderful. All right, so please make a note of that because you're going to be needing those skills shortly or in the near future, right? So you cannot forget how to do that. You're going to get practice worksheets still, so don't worry ahead. I think Bernard asked me for some worksheet today, so I did explain to him that I don't just send worksheet for every topic I teach. My worksheet has to have a compilation of topics taught, right? So it can't be a case where, oh, me teach fractions, me send a practice worksheet. No, I'm not going to load you up with 25 fractions. That's crazy. Because you're only going to get one, sometimes you'd even get none on the exam. So I want to give you practice questions on fractions. I want to give you practice questions on areas and volume and then approximation. So it should be a nice worksheet that has maybe like 5 questions of each. So you have, so when you're doing your practice, you're doing multiple things one time, and you're not just practicing in a vacuum. Okay? So if you so just give me some chance, guys. Let me just put together the worksheet properly. All right. All right, let's continue here. So now we're going to look at some mixed fractions now. So let's say that you're asked to once again evaluate. All right, so evaluate 3 3/4 plus 1 2/3. All right. So if you get a fraction like this en el futuro in the future, right? Naturally, the moment that you see a mixed fraction, ladies and gentlemen, as discussed earlier when we were doing the mixed fraction conversion, we said that the moment we see a mixed fraction, we need to convert that mixed fraction to an improper. So naturally, we're going to say 3 times 4 times 3. Hold on, let me just get my reading here. Hold on. So we're going to have 4 times 3. That's what we were doing earlier. 4 times 3 is 12. And then 12 plus 3 is going to give us 15/4. Make a note of that. All right, 4 times 3 is 12. 12 plus 3 is 15/4. Plus 3 times 1 is 3. 3 plus 2 is going to give us 5/3. All right. And I don't think anybody in here is silly enough to go ahead and say 5 plus 15 is 20 and 4 plus 3 is 7. That is like the worst thing that you could ever do on an exam. The examiner is going to be so mad. He'll probably just mark the whole question wrong because, I mean, come on, guys. That's not how you work fractions. Okay? Right. There's just some acceptable way to get things wrong, and there's just some unacceptable ways to get things wrong, guys. Honestly. So if after 3 months I see person saying 15 plus 5 is 20 and 4 plus 3 is 7, it means you're not in sync with the class, nor are you expressing any form of interest in learning. Okay? So remember now, guys, you're gonna go ahead and draw a line here. And you're going to place the number 12 here. How did I get the 12? I multiplied the 4 and the 3 here. So 4 times 3 is 12. Ready, let's go. So 4 will go into 12 3 times. You put that 3 right at the top here. And then 3 into 12 goes 4 times. Put that 4 at the top here. And then we go ahead and produce 15 times 3 is going to give us 45. And then we're going to end up with 4 times 5 is going to give us 20. So we end up with 65 over 12. Now, unlike the previous example where we would have ended up with 12 over 65 and we would walk away and say, okay, boom, our answer is right. At this point, if you leave the answer as 65 over 12, most instructors or markers will say that the answer is incomplete and they will take off a half a point, because 65 over 12 is not the lowest term. It's not the lowest because 12 can go into 65. You just need to figure out about how much time. So 12 can go into 65 and you can figure it out on your own, in your own way. 5 times remainder 5 over 12. You can confirm that on your own, okay? 5 times 12 is 60. I need to get to 65, so I have a remainder of 5 over 12, all right? So that is how you do that. Again, it is your choice. Do you want to sacrifice losing half a point, or do you want to make an effort to figure out how much times can 12 go into 65? We are going to go a little bit over our usual closing time, but that is because we had some earlier glitch with the device, all right? So don't mind me. I might go over by 5 or 10 minutes just to get across, just to finish the objective for tonight, okay? All right. Any questions thus far? The floor is open. Do you have any preguntas? Nothing? Can I get some reactions, please? Just to make sure that everybody is up to speed. Beautiful. Loving. Everything is clear. Simone, nice. Well done. Perfect. Grace, and I see you. Tishana, Randa, I see you. Alia, I see you. Latisha, I see you. Akila, I see you. All right. Lovely. Fantastic. Let us continue then. Yes? All right. So we are now going to look at an example of subtraction. I'm going to put it side on side so you see the comparison. Okay? Side on side so you see the comparison. Lovely. So let's go over here. We end up now with something like 2 and 3 over 5 minus 1 and 2/3. Okay? 1 and 2/3. Where's my eraser? That doesn't write properly. 1 and 2/3. So once again, you're seeing the presence of mixed fraction. Go ahead and convert your mixed fractions to improper. So we're going to go ahead and we're going to say 5 times 2 is 10. 10 plus 3 is going to give us 13 over 5. I don't know what's going on with this 13 over 5 here. So 13 over 5 minus 3 times 1 is 3. Plus 2 is 5 over 3. All right? Lovely. So now we're going to go ahead then and we are going to find the LCM. To find the LCM once again, for the 4th time, we're going to go ahead and multiply the two numbers at the bottom. 5 times 3 is going to give us 15. 5 into 15 will go 3 times. And 3 into 15 will go 5 times. All right? 3 times 13, you can use your calculator and you'll find out that it is 39. And 5 times 5 is going to give us 25. If we produce this calculation, we should end up with an answer of 14 over 15. All right? And unlike the previous example where we had 65 over 12, we end up now with a nice answer of 14 over 15. This does not need any conversion because 15 cannot go into 14. So we have arrived at our final answer. Okay. All right. And so therefore now we're going to go ahead and just bar this off right here. And then we're going to look at an example now where there is 3 fractions then. Okay. All right, and the 3 fraction ones is not very common, but just in case you guys are proactive, and you guys are actually looking into working additional questions, then you may end up seeing stuff like this. Let's say you end up seeing something like 5 and 3/4 minus 2 and 1/7 plus 1 and 3, 1 and 2/3, 1 and 2/3. I don't want the 7, hold on. More some small numbers like 5. So some small numbers like 5. So 2 and 1/5. It can work still in but I just don't want any big numbers to start off.
Sir, you're muffled.
Pardon me?
Sir, you're muffled.
I'm muffled. Are you hearing me now?
Yes, sir.
Okay, so 5 and 3/4 minus 2 and 1/5. And that's going to be plus 1 and 2/3. All right. So obviously, the more fractions you have is the larger the denominator or the LCM is going to become. But let's not worry ourselves. Let's take our time and try to figure this out. As per usual, I hope nobody is using the old technique where teachers used to say 5 minus 2 is 3 and then 3 plus 1 is 4. Please don't do that, guys. Don't do what you used to do because what you used to do never worked. That's why you're here. Not true? So you're going to do something new, right? Stick with the evil way you just currently learn, right? Don't do all that extra stuff and then convince yourself that it's easier because evidently if it was easier, then you wouldn't be here learning this one here, okay? So try stick to what you know right now. This is what you know right now, okay? So 5 and 3/4 minus 2 and 1/5 plus 1 and 2/3. We are going to go through our usual steps of first converting all our mixed fractions to an improper fraction. So we're going to go ahead and say 4 times 5 is going to give us 20. 20 plus 3, that's going to give us 23/4. And then we're going to end up with a minus sign here. We're going to have 5 times 2 is 10. Give me a second, guys. Hold on. So we're going to have 5 times 2 is 10. And 10 plus 1, that's going to give us 11. That's 11/5. Plus 3 ones 3. That's 3 times 1 is 3. Plus 2 is going to give us 5/3. All right. Now, there are persons that will find getting the LCM a challenge, but the LCM does not change. Hello, Zanaya. Hi, Tanisha, what's up? All right, so finding the LCM is not going to change. So it's going to be the same as what we did before. We're going to draw a line and we are going to multiply all 3 numbers at the bottom here. Okay. Lovely. So let's go ahead and do that. So now we end up with 4 times 5 is 20 and 20 times 3 will give us 60. All right. So same as how you find the LCM when it's 2 numbers. It's the same way you're going to find the LCM when it's 3 or when it's 4 or when it's 5. Evidently for exam purposes, guys, the most you'll probably get is something like what you see on the screen. At most, because we know the multiplication and division yet. So as it relates to addition and subtraction, the most you're going to get is 3 fractions to add and subtract simultaneously. All right. So LCM. All right, watch this now, guys. Remember that some of us here, we do struggle with our timetable. If you're honest to yourself, you say to yourself, I am one of those persons that have a hard time with the timetable. So here's how we can manipulate the timetable. Watch this now, guys. Look at this. Pay close attention to my cursor, right? I want to find out, watch how I'm going to mark up on the screen now. Okay, watch now, guys. I want to find out how much time 4 goes into 60. The problem is I'm not very good with my timetable. So what can I do? Is there a way where I can find out how much time 4 goes into 60 without the calculator or without knowing my timetable? Yes, there is. Just multiply these two numbers right here. So 4 will go into 60 when you multiply the next two numbers that is not there. Okay? So evidently that will go approximately 15 times. I know. I get a lot of oohs and ahs today when I showed students them. They were like, what? No way. That works all the time, sir? Yes, it works all the time. So yes, I know probably some of you guys will be like, what? No way. That's not true. Try it for the next number then and see what happens. Yeah, man, it works. Remember, most of the time, guys, a lot of us aren't very, what I would say, versed with the timetable. So you have to find means and ways to go around the timetable. All right? So watch this now. 4 goes into 60. 4 goes into 60 15 times. I mean, you can always use your calculator and just type 60 divided by 4. It's going to tell you 15. So you're going to put that 15 at the top there. Okay? Watch this now. I want to find out one more time. 5 goes into 60. Guess what I'm going to do? Multiply them 2 here. And that's going to give me a total of 12. All right? So that is if I'm in the exam and we don't have a calculator. So that's going to be 12 right here. All right? And then now we're going to say 3 goes into 60. I'm not very good at the timetable, so what I'm going to do is just multiply the 4 and the 5, and it's going to tell me that the answer is 20. All right? So 3 into 60 goes 20 times. Multiply this by 20. All right. Now, let's get into it then. We're going to go on your calculator now. Can somebody confirm for me what is 23 times 15? I don't want to have to switch my screen to get the answer.
345.
345. Can somebody else confirm that, please?
Yes, sir.
All right, lovely. What is 11 times 12? I believe that is 132. Can you confirm?
Yes, sir.
And then 5 times 20 is going to give us 100. Not true? All right, so now we're going to just type everything on the line into our calculator, and then you tell me what answer you get. We don't need to do no O and have nothing. We're at the stage now where O and have was just an introduction to prevent you guys from making sign errors. We passed the level now, we have a calculator, let's use it up. So what is 345 minus 132 plus 100?
Sir, 313.
Can somebody confirm that answer, please?
Yes, sir. 313.
Yes, sir.
300. Very good, 313. All right. So what's going to happen then, guys, if you leave the answer at 313 over 60? You're going to get half a point lost. You're going to lose half a point. All right. So losing half a point is just kind of unnecessary. All you have to do is to figure out how much time 60 goes into 313. So you can just do your own little maths and figure it out. From my eyesight where I'm looking at here, the answer is going to be 5 times remainder 13 over 60. All right, 5 60 is 30. So 5 times 6 is 30. So 5 times 6 is 300 plus 13 back over 60. So that's my final answer here. All right, lovely. All right, ladies and gentlemen, we have arrived at the objective where we wanted to reach. The only thing I didn't get a chance to do was to give you a few to try. However, we can always wait for the worksheet that will be uploaded to the Google Classroom. For those of you who are new and you don't know what the purpose of the Google Classroom is, that is where I communicate with my students in regards to like practice paper, updates, notice, and I use the Google Classroom to send updates rather than filling up the WhatsApp group with a bunch of unnecessary messages. Okay, so that's what I use it for. If you don't have access to it, I'm going to forward a reset link into the group right after the class so new persons can access the Google Classroom and you can see what we've been doing thus far. Okay. All right. So with that said, ladies and gentlemen, have yourselves a peaceful and safe rest of night. And I'll see you guys next week. Stay safe, stay out of trouble, and looking forward to seeing you guys next week again. Okay. Good night.
Good night, sir. Good night, everyone.
Good night, everyone. Good night, sir.